Once the nail is introduced, you reapply the target arm to the L handle. This is done by reattaching the shoulder bolt. It's very important at this time that you use the wrench to assure that the locking bolt is tight. You can see if the locking bolt is not tight, what rotation will do in terms of finding the interlock. Once the target arm has been placed on the L handle, you decide if you want to use 1 screw or 2 screws. Use 2 screws in a comminuted fracture and 1 screw in a more stable fracture. If you decide to use 1 screw, use the screw slot in the slot nearest to the fracture. If you use 1 screw and place it in the distal slot, you'll leave a stress point in the nail. When placing the interlock, you have lined up the hole. Use the alignment pin to dimple the skin. This dimple in the skin will determine where your incision is made. If you use 2 screws, use both of them through the same incision. If you use 1 screw, you don't need a larger incision, but you must make the incision big enough to get the cannula and the finger of a surgeon in, so the cannula will not walk across the bone. Once the skin has been dimpled by the alignment pin, use that as a guide for your incision. If there's muscle in the way, use the periosteal elevator to dissect through the muscle. Once you reach the bone, turn the periosteal elevator at 90 degrees to remove the soft tissue and periosteum from the bone. Introduce the cannula to the bone. Sometimes it's necessary to use a curved clamp to remove the soft tissue from under the cannula. If there's soft tissue between the cannula and the bone, the cannula can walk off. The small pilot hole is then made using the small drill guide. We have 2 drill guides, the small one and a large one. Use the small drill guide to guide the drill bit in through 1 thickness of the cortex. Make a hole in 1 cortex using the small drill bit. Stabilize the tip of the cannula. You can feel the drill bit sink into the canal. Stop drilling at that time. Always remove the drill using the forward speed of the drill. Substitute the small drill guide for the large drill guide. Use the step drill to enlarge the hole. The step drill has a smaller end which is used to follow the original pilot hole. The step drill is necessary to enlarge the hole when electricity is not available. Please recognize that we often use a hardware drill. We use drill covers and a sterile chuck so that drilling can be done sterilely using a hardware drill. The hardware drill often has the same RPMs as an orthopedic drill, which is much more expensive. The step drill is then used to enlarge the hole. As you're going through the cortex, it all of a sudden becomes harder. It becomes harder just as it goes through the cortex. The stop really occurs when the step drill engages in the slot of the nail. Stop twisting at that time and remove the step drill. The solid slot finder is then used and placed in the slot. When you're introducing the slot finder, first line up the flats of the slot finder with the L handle and push the slot finder in. Don't try to get it in by rotation. This slot finder is caught in the hole because it does not engage the nail. This is not uncommon using sawbones. The screw hole broach can be used to remove the bone from the bottom of the hole. The screw hole broach is used by removing the drill guide and using the cannula for a guide. Once you've cleaned out the hole with the screw hole broach, reinsert the solid slot finder. Put the large drill guide in and place the solid slot finder in. You can see that it's not in the slot of the nail because it turns all around. So rotate the nail. The rotation stops at 10 to 15 degrees. It means you're in the slot of the nail. This is the sign feel. And this is a very important idea to have. Don't put the slot finder in and rotate at the L handle. Rotate the slot finder, and if it stops at 10 to 15 degrees, you're in the slot of the nail. Take the cannulated slot finder and place it in the slot of the nail. Note that the cannulated slot finder doesn't rotate as much. The reason the cannulated slot finder doesn't rotate as much is because it's a little wider than the solid slot finder. This also means that sometimes you can get the solid slot finder into the slot of the nail through the hole, but the hole stops the cannulated slot finder, and then you must use the screw hole broach again. Once the cannulated slot finder is placed, and you determine again by rotation that it's in the slot of the nail, drill the hole in the far cortex. When the hole is drilled in the far cortex, place the depth gauge into the cannulated slot finder, and it will stop by the soft tissue on the other side of the bone. I'll have to hold it here because there's no soft tissue. After you've placed the depth gauge and you're sure that you're in the soft tissues, remove the cannulated slot finder and remove the drill guide. It's important to use your tactile sense. Measure the depth of the screw on two sides of the hole and add 4 millimeters. This measures 36 millimeters, and so we'll use a 40 millimeter screw. Once you've determined the depth of the depth gauge, add 5 millimeters. The reason you add 5 millimeters is so that 2 threads will be prominent on the far cortex and 2 threads prominent on the near cortex. Our screw is made so that the middle of the screw is solid and therefore it is stronger. As the screw is being screwed into the cortex, raise the cannula so you can look at the progress of the screw. This is important in osteoporotic bone because sometimes the screw can go all the way through into the canal without your knowing it. You can see here that the screw is prominent on the far cortex and prominent in the near cortex. This prominence in the near cortex will mean removing the screw, should it become necessary, will be much easier. You can determine that the screw is in the slot of the nail by rotating the nail. This is another signed feel. Once you've determined that the screw has entered the slot of the nail by rotating the L handle, compress the fracture site. The compressor is used to compress the fracture site as well as remove the nail. It is composed of three parts: the compressor that attaches to the locking bolt, the rod, and the slap hammer. Compression of the fracture site. This is also used to remove the nail if necessary. When you're removing the nail, it's a good idea to remove the screws, all but one screw, until you have this attached, because sometimes the nail will be pushed down in the canal if there's not a screw through a slot. Once compression of the fracture site is done and you'd like to add another screw, put an alignment pin through the head of the screw and place the screw in the more proximal of the two holes like we did for the distal screw. Once the distal screw or screw has been placed, the proximal interlock is done. The proximal interlock goes a lot faster. The proximal interlocking screw is accomplished by marking the skin with the alignment pin. I advise 2 screws in the proximal interlock. Make an incision down to the bone, remove the soft tissue from the bone. Place the cannula and the small drill guide drill a hole through both cortices. You don't use the slot finders for placing the proximal interlocking screws. The hole is enlarged using the step drill and the large drill guide. It's not necessary to place the slot finder into the nail slot. When measuring the length of the screw with the depth gauge, be sure you remove the large drill guide or you'll have a screw place that's too long. This one measures 45 millimeters, so we'll use a 50 millimeter screw. It's also very important when you're doing the proximal interlock to raise the cannula to look at the progress of the screw going in. The bone in the proximal femur is not as thick as the bone in the diaphysis, and it's easy to place the screw all the way into the trochanter. After the proximal interlocking screw is placed, use the same technique to place the proximal interlocking screw in the other hole of the nail. Notice that there's a hole in a slot in the proximal end of the nail. This becomes important if you're feeling the step drill go into the nail slot here, but it won't go into the hole here.